Hello, this is Paul from Foresight Tech. In this lecture, we are going to deal with the product rule for derivative. And the product rule is one of the most important rule in Calculus 1. Okay, there are a lot of functions, so we need to use this product rule to find the derivative. And let's see. In this video, later I will going to introduce the product rule first, and also give a proof. And then I have 3 questions we are going to practice together, okay, for the product rule. So here is the product rule. And what is the product rule? So you can see from the left side is the prime of the product, which means we are going to find the derivative of a product. F is a function, G is another function. Okay, that's the product. That's why we call the product rule. Okay, and at the right side, so you can see is 2 terms added together. The first term is just the f times g, but it's f prime times g, which means take a derivative to the first term. Okay, the second is take a derivative to the second term g. And so for some other book, so probably someone or you find other form, okay, of the product. So like we switch the order by commutative, right? So someone use g times f prime plus f times g prime, or some also use f times g prime plus g times f prime, means put the prime to the second term on both terms. We did not use that form because we are going to keep the same order of fg. Can you see? The left side is f times g. So the right side we also use f times g, f times g. Okay, I hope you understand. So if you like another term, no big difference. Exactly the same. Okay, so you can use yours. See which form if you like, then you use which form. So we keep this form. We will keep the same order of the first function, the second function, the first derivative, the second function, the first function, the second derivative, like this. Okay, so here we have another notation. So we call it the Laplace notation. Okay, Laplace, you know, is a very famous guy, right? We introduced it before. So here, and the Laplace notation is dy dx. Of course, y is the product of 2 functions. Fx times gx is just f times g, which means we are going to take a derivative to the left, right? How to find the derivative? Okay, so here is just follow the formula. The first function take a derivative times g. The first function take times the derivative of the second function. This is the derivative of g, right? Okay, so Laplace notation is exactly the same as this prime notation, and we are going to just use the simple way. Okay, prime notation, and later I'll give you a proof. Now I'm going to look at this simple example. So this example exactly is product, right? The first function is x, the second function is e raised to the x power. Okay, which means now we have a product. We need to find a derivative. How to do? So everyone, you can see here, right? This product. Here is f, the first function. So here is g, the second function. Now we can just use the formula. See, this is the way. So how we can use the formula? Okay, so the formula give us is this. The first function take a derivative, right? Which is x take a derivative times the second function. And then plus the first function times the second function take a derivative. Okay, see, I keep the same order. X, ex, x, ex. I just take the prime to the first, take prime to the second. Okay, so it's easy to remember the formula. Now, what do we do? And this is a power rule, right? Power function. This is a natural exponential. We already learned. So here is 1. I ignore the 1, therefore we have ex power. So the second, so here is x times what? E raised to x power itself, right? Okay, and somehow you can stop here, or if you like, you can factor out the common factor, e raised to the x power. Therefore, this is 1 left and x left times e raised to the x power. Okay, so I stop at here. See, and at least so you can see the product rule is easy to use. All we need is just directly follow the product rule. And now we're going to prove. Okay, here I already wrote something. All we need is what is just the definition, the limit definition of product. Okay, so we need to go back to the definition again. So you can see all we need is find the derivative or the product, right? So the product is f(x) times gx. So the easy way is just set up capital F as the product, and then we're going to take a derivative to f. And the first step we use definition, okay? And the second step just plug, evaluate the capital F. The capital F at x plus h, which is these two terms at x plus h time together, right? And evaluate the capital F at x, which means just f(x) times gx. Okay, so here is just evaluate. Now is the major one. Okay, so remember we have to separate into two terms plus together, right? How to separate? So here we have a little trick. I'm going to show you so how to do. We need to separate the f and the g. Now is mixed together. Okay, and then we add the term or minus the term, and then we can separate the f and the g. So what kind of term? I will put the term here. Can you see? I will put the term here. I will add these two terms. Can you see? I will add these two terms. The first term I will going to minus a term. Okay, I will going to minus f. I will going to minus f(x) times g at x plus h. Okay, what does it mean? After this first term, I minus this term. Of course, if we minus the term, we change the value. Therefore, I plus the same term again. See, you see, if I minus the term, then I plus the term, of course, we did not change any value, right? However, this time we have 4 terms on the top. Okay, the first 2 terms we group together becomes these 2. Okay, the first term minus this, right? The second 2 terms we group together, which is f(x) g here minus f. You cannot see here. Okay, which means we just add minus 1 term, add the 1 term. Therefore, the original 2 term, now we have 4 terms, right? And the first 2 terms we group into this. Okay, group the first 2 terms, group the second 2 terms, which is this term we put here, right? Minus this term we put here. Can you see? These 4 terms now. Of course, we separate the bigger fraction into 2 fractions. Okay, now you see 2 fractions. And why we have 2 limit? Because, you know, is the sum law, right? So the limit law we used. Okay, up here is the limit law we used. Of course. Okay, so now it's much better. We have 2 limit, and each limit now is much simple. Why we say this? Because you see, the first limit, when we look at the top, what we found? We found g at x plus h. G at x plus h, they are the same, which means we can factor g x plus h out from the first term, right? If we factor g out, what we left? We left a, we left f, which means we separate the f and g. That's the idea. Okay, the second is the same. Can you see fx the same? That's the common factor. You can say factor the f out. We can separate the f and the g. We finally separate all of the limit, right? Okay, so let me show. After we separate, what do we get? Okay, so all here is just to say is factored out the common factor, right? Okay, so you can see the first we factor the g. Up here is the red one you can see. Okay, here is f. here is g, totally separate. Okay, the second limit is f should be here, right? But remember, f is just what? Okay, so I put the f here, factor the f out. What we have is g, f and g separate. Okay, completely separate. Good. Now we're going to here, and let me see now what to do. We just evaluate the limit, right? So how do you evaluate the limit? So let me look at it one by one. The first limit is two terms times together, which means the limit of the product. Do you remember we have a product rule, right? See, we can change it to the product of two limits. The same for the second. Of course, we don't need to do the product. So fx has nothing to do with the h, which means we can see this fx nothing to do with the limit is like a constant number. We factor the constant number out. Do you remember what the name? We call the constant multiple rule, right? Okay, so these both of the rule is limit law. Let me put it here. Now we use the limit law. We can get what? We use the limit law, so we can get the first two times together, the second. Okay, almost one by one. We're going to see how about the first limit. Okay, if you imagine this is just the definition of the derivative, right? Which is the derivative of f. How about the second limit? Okay, and this we can, if we directly substitute, we get the gx. Can you see? Can we directly substitute? Yes. Because of what? Because of continuity. If here, if someone look at the second term, it's continuous, right? Or if I say it's a continuity, so the answer is gx. You can directly substitute. That's why here is gx. Okay. Why is it continuous? Because g is differentiable. Differentiable, then it should be continuous, right? Okay. Now we move to here. F is still f. How about the last limit? Of course, is the derivative. Can you see? We finally have what? This is the f, the first prime times the second, the first times the second prime. Here is the definition. Here is the result, right? Okay, and this is the proof. And if we go back to go over a little trick is just add the term minus the term, separate the f and the g. Okay, this is a big idea. Now what we left is going to practice the rule, and this rule I have 3 questions we practice together. Okay, let me look at the first question. The first question is the normal way. Okay, what do we have? Here is the f, here is the g, right? Or you can say here the first function, here the second function. Okay, which means the 2 functions times together. Definitely we can directly use the product rule. Okay, let me show here. We will directly use the product rule. Okay, this is a product, right? This is a product. We have a product rule guide us to find the derivative. Now the derivative already right here equals what? We copy the rule. Okay, the rule is the first function take a derivative. Okay, let me see. First take a derivative. What is the first function? Is 3x squared minus 5x. Okay, times the second function, and then what? Plus the first function is here, I copy, and then times the second function, take a derivative. Is this the rule? Yes. This is just what? So we keep the same order. The first times the second. The first take a derivative, the second take a derivative. Okay, so now what do we do? Directly. Okay, so directly get the answer almost. For the first is a polynomial. The last topic we did. What is the derivative of polynomial? We can use the linear property, right? And then combine with the power rule. Okay, if someone remember this, the first term take a derivative, and which means 3 times x squared take a derivative. What do we get? There's the power. X is to the second power, take a derivative is 2x, therefore 3 times 2 is 6. So we have 6x. And the second is minus 5. Okay, because the arithmetic derivative is 1. 5 times 1 is 5, and then we put the parentheses. Okay, and then times ex, right? This is the first. The same, I will going to add the second. The second is 3x squared minus 5x. Okay, what is the derivative of ex itself? You remember this, right? The natural exponential function has the same derivative as itself. Okay, we don't stop at here. Why? We can simplify. How do you simplify? Can you see? Here is the common factor. We can do what? We can factor out. Okay, we can do this. We can factor out the common factor. Okay. Okay. After we factor out, see what do we have? Now we have this. Okay. We have 6x minus 5 left, minus 3. Not a minus, plus 3x squared. So I changed the order a little bit, so it will look as a little better. 3x squared. What is x term? 6x minus 5x. We have x left. How about the constant term is 5? Okay, you also can write it in this way, because what? It is a polynomial. The normal order for polynomial is go from the highest term to the lowest term. Okay, and then times ex. Can you see? Here is the final answer for this question. Okay, easy to use, right? Okay, very easy. Okay, we just directly follow the product rule. Therefore, you see product rule is important, really important. Let me see these questions. Can you see? Okay, so now, how about the second? How about this question? Yes, it's a product, right? You see the product the first time the second. Of course, if you like, you can use the product rule. But hold, think about it. Do you remember the last one we did the similar questions? If we expand these two terms by Fourier or whatever something, do you remember it's a kind of a linear combination of power function and easy to get the results. If someone you remember, we did that, right? Okay, so here we do the same. Stop down, just use power rule. Why? Because power rule later you will find that you still need to expand. Okay, we do this. We expand at the first step. Okay, this is important. Why? Because if you expand, this should be better than, okay, better than you using product rule. Okay, you will see why. I will going to show you. Okay, so but how do you expand? How do you expand? You can use Fourier, but we were not going to use Fourier. We were going to use another. Can you see that the difference? The first is the difference. The second is the sum. Difference times sum. We call it the difference of squares. If someone remember, that's what? That's the difference of squares. I can directly use the difference, okay, of squares. If someone you remember this formula, we use it a lot of times. We use this directly, we can find it. Okay, so let me going to show. I put it here. HU, I expand should be going to this. The first term square minus the second term square. Do you remember this? This is just what? This is just the difference of squares. So the first term u, take the raised to the second power. The second square root of u raised to the second power. The difference of squares. Why do we do this? Because now what do we get? We get the u square minus u. How simple is the function of hu? Okay, it's what? It's a polynomial, right? Simple. If it's a polynomial now, what do? We can directly take a derivative to this polynomial, which is the first take a derivative minus the second take a derivative. Of course, take a derivative to u. Okay, so the variable is u. So what do we use? We use the difference rule. Okay, if someone remember this, the difference rule. of derivative. Okay, and then what do we have? We directly have the answer already. What is the answer? So here we get 2 times u, right? Here we get 1, and this is the answer. Okay, so this question just give you a hint. Okay, not always use product rule. Okay, not always use product rule. If you can expand something into like a polynomial or linear combination of power functions, just expand. Keep in mind, expand. Let me look at the one more question here. I think you find it right. So 2 terms, if we expand, we will find a kind of polynomial. Okay, if somewhere like, of course, you can use product rule because you have the first term, the second term. You can try. Okay, so the product rule is much complicated. Okay, than expand. So what do we do here? We just expand. Okay, so let me put it here. They are going to expand. And as the last question, if I expand, it should be much easier. Okay, then directly use the product rule. How do you expand? This time is not a formula. We have to use Fourier. Okay, you remember the Fourier. Okay, I have to use this Fourier. So expand the first, and then we have the out, right? And we have the inner, and we have the last. Do you remember this Fourier? Okay, so now we use the Fourier directly to get the function f at y equals what? We look at the first term. Let me write all the terms so you will see it clearly. Times y did the first, right? What is the out? The out is this. So here times 5y squared. Okay, this is the out. The inner is minus 3y raised to the 4th power times y. How about the last? The last is minus 3 over y raised to the 4th power times 5y squared. Okay, very long, but don't worry. Okay, we can simplify. We can just use the quotient rule of exponent. So we cancel y. The first we get 1 out of y. But 1 out of y we will write into this form. You know what? This is the power, right? We wrote the results as a power form. Okay, so the same for the second. We cancel y squared, we have 5. Directly plus 5. How about the third term? You can see the third term. I can cancel y. We have y raised to the 3rd power to the bottom, which means a negative exponent. If I write it as the power is this. So it's minus 3 times y raised to the negative 3rd power. You know the reason, because we see this as a power function. We can directly use the power rule. And the last time we did, right? Okay, how about the last term? 3 times 5 is 15. Y squared, y4, we cancel y squared, we get a y raised to the 2nd power to the bottom, which means y raised to the negative 2th power, right? Okay, let me write it. It's negative 15 times y raised to the 2nd power. Yeah, that's good. So now what do we have? We have a linear combination of a power function. We can directly use the power rule. Okay, the linear property. Let me write down here. For someone remember this, we call the linearity. Okay, so I'll use this simple linearity or linear property. Okay, if I use linear property, the result is like this. Okay, y f take a prime, take a derivative is the first term, take a derivative plus the second term, take a derivative minus 3 times negative 3, take a derivative. The constant coefficient does not matter, remember that, right? Minus 15 y negative 2 take a derivative. Okay, all the derivative is to y, and then is the power function, right, directly. So the first is a negative, take it down, and then negative 1 minus 1 is negative 2. Okay, the second is 0. Constant number has a 0 as a derivative. The third term is take it down negative 3, which is a negative 9. Negative 3 times negative 3 is a positive, sorry. So it's a positive 9. And then y. Negative 3 minus 1 is a negative 4. Good. The last term, take it down negative 2 is a positive 30, right? Okay, and then negative 2 minus 1 is negative 3. That's the results, right? So we get it. That's all. Thank you. And if someone you like my videos, or if you have any questions, please leave your comments. Okay, if you like it, give me a like. Thank you. And or you can subscribe to my channel for more videos in the future. Okay, and the next video, what we are going to do, the next video we are going to deal with the quotient rule, which is also another important rule. And I hope to see you next time. Thank you, everyone. Have a nice day. Bye.